Hello, welcome to lesson 11, our last lesson of the unit. All right, guys? Yay, the last one. Okay, enough of that. So what does it mean for a function to be even, odd, or none of the above? We're going to talk about that today, and hopefully by the end, you will be able to recognize an even and odd functions from graphical and algebraic representations. So basically, you're going to look at a graph and you're going to tell me whether it's odd or even or none of the above. And you're going to be able to take the equation of a function algebraically and test whether it's even or odd. And I'm going to show you both of those today. It's pretty easy, not too shabby, and lots of fun. At least I think so. Right? So take a minute, pause the video, write this down. All right? Moving on. Think about it. Consider the equations and graphs below. What makes a function even and what makes a function odd? Hint, look at the degree of the equations and symmetry of the graphs, all right? So I'd like you guys to take a minute and for each one of these examples, 1, 2, and 3, I'd like you to tell me what you notice graphically about these, all right? And graphically, they tell us that each one of these is even, one is odd, and one is not an even function, and one is not an odd function. Can you tell me why that this is the case? I want you to notice something about the graphs. There's something kind of special that happens if they're even, and that happens when a function is odd. So take a minute, pause the video, and try and answer these questions. All right, so graphically, what it means to be even, so graphically, let's write this down. Graphically. Okay, a function is even if it reflects across, well, that's not going to fit, across the y-axis onto itself. And if you look at function number 1 here, if you were to bend that in half across the y-axis, in a sense you're taking a piece of paper and you're folding it in half and you're seeing if the graph is on itself, right? That's what it means to reflect across the y-axis. So for each x value, right, its negative has the same corresponding y value. All right, so you can fold it in half or you can bend them across at the y-axis under the same line. That's what it means to be even. To be odd, so a function, so to be an odd function, So a function is odd if the graph has symmetry about the origin. So you have to think back to geometry. What does that mean? Symmetry about the origin. That means that I can rotate my graph 180 degrees about the origin and the graph does not change. So at number 3, it's an example of an odd function. And if we take all these points and we rotate them 180 degrees, right? All the points, right? That's going to go there. This one is going to rotate around to here, right? The graph is still the same. It rotates 180 degrees onto itself, okay? That's what it means to be an odd function. So examples are functions 2 and 4. They're both degree, well, function 2 is degree 4, or was that degree 6? Sorry, degree 6. And function 4 is degree 3. So the degrees are both even, or one is even, one is odd, but that doesn't mean that the function is even or odd, all right? Okay, so let's take a look at what that means algebraically now, all right? Hopefully you understand what it means graphically. Let's take a look at what it means algebraically. So, for a function, so algebraically, all right, so algebraically, even means f of negative x equals f of x, and odd means f of negative x equals negative f of x. And you're probably wondering, Mr. Moore, I don't understand this right now. Well, let's actually look at some examples where we try this, and let's see what we get, right? So remember that f parentheses, whatever's inside parentheses, right here it's negative x. That means I plug in negative x into my function for all the x values, and we see what we get. Okay, so let's try that with function number 1. So we want to find f of negative x. So f of negative x equals negative x to the 6th power minus 2 times negative x to the 4th power minus, sorry, that's not a 2, minus negative x squared plus 1. All right? Well, anything to an even power, right? Any negative to an even power is always, that's right, positive. So we get x to the 6th minus 2x to the 4th minus x squared plus 1. Well, to me, that looks like my original function equals f of x. So f of negative x, when I plug in a negative, I always get out the same thing as I get when I plug in a positive, which is f of x. So this function is even. All right? It's even. So we plugged in negative x, and we got out f of x. This is actually a proof for showing that a function is even, believe it or not, which is something I may ask you to do. All right? So if it says show, that really means prove. Okay? Let's look at number 2. Let's do the same thing. We have to plug in negative x, right? So I have, let's use a different color this time. Let's go with, so I have f of negative x equals negative x to the 6th power plus a negative x plus 3 times a negative x cubed. So we know that a negative x to the 6th power is really just x to the 6th. And then that plus negative x, that looks like, so that's just minus x plus 3 times a negative x cubed, right? Because there's an odd number, which means it's still negative. So that means I have x to the 6th minus x minus 3x cubed. Is that the same as my original function? Does this look like this? No, they don't, right? So we can say that this function is not even. Okay, so it's not even. That means now we need to check to see if it's odd. So notice it says negative f of x, so I need to factor out a negative now. All right, let's factor out a negative. So it's a negative, so if that was positive x to the 6th, it becomes a negative x to the 6th. All my negatives become positive. Does that look like f of x inside? Is this f of x? No, it's not f of x, right? So this function is neither even nor odd. It's neither. All right? So it's not even, it's not odd, it's just something else. Okay? Oops. Okie dokie. Let's try 2 more and then it'll be all yours. All right, so we have function 3. I'd like you to actually do these 2 on your own and see what you get. All right, for number 3 and number 4. I want you to tell me whether they're odd or even or none of the above. All right, odd, even, or neither. Are you trying it? I said try it. Don't wait for the answer. All right, so hopefully you did this and you got these 2 two equations at the end here. All right, so when we plugged in negative x, we got a negative x minus 2x cubed plus x to the fifth. I notice that that is not the same as f of x, the original function, so I factor out a negative. When I factor out a negative, I notice that that's the same as, what's that the same as, guys? That's the same as negative f of x. So that means that this function here is odd. Okay? Looking over here at the green one, I'm looking at the green one here, and what do we notice? Well, we plug in a negative x, and we get a negative x cubed plus 2x squared. Is that the same as f of x? No, so it's not. This function isn't even. I factor out a negative. All right, it still doesn't look like f of x, so it's not odd, so this function is neither. All right, it's none of the above. Now I would like you guys to do these problems. I'd like to see your graph, sketch a graph, right? You don't really need a, well, you can use the online graphing calculator from Wolfram Alpha, right? For each one of these to sketch the graph. And then I also want you to determine algebraically whether they're even or odd as well, right? So I want you to graph these, tell me what they are, and support it algebraically, okay, for all three of these. To graph them, just use the internet, all right? I hope you guys have a good night and you get caught up on everything, and look forward to seeing you the next day we have class. Good night, gentlemen.